All right, let's talk about chameleons. Because here's the thing, almost everything you probably think you know about why they change color is wrong. So let's just get right into it. We've all seen it in cartoons a million times, right? A chameleon wanders onto a checkerboard or a plaid blanket and poof, it's a perfect match. So why do they really do it? I bet you think you've got the answer. Well, here's the big twist. It's not to blend in. I mean, sure, it can sometimes help them hide, but that is not the main reason. Not even close. The real story is so much cooler. Yeah, so forget camouflage for a minute. The best way to think about a chameleon skin is like a high-tech reptilian mood ring. Seriously, their skin is basically a living billboard, broadcasting exactly what they're thinking and feeling to the world. It really just boils down to two main things. First, social communication. They're literally talking to other chameleons with their skin. And second, something called thermoregulation, which is really just a fancy way of saying they're controlling their own body temperature. I love this idea of a living billboard. Just imagine two male chameleons facing off over a branch. They're not just hissing, they are lighting up in these insane, vibrant yellows and reds, like a couple of neon signs screaming, "Hey, this is my branch," or "You want to go?" It's a whole visual language of intent. Okay, so let's break down how this one skill does two totally different jobs. On the social side, flashing bright colors can mean "I'm the boss here," or it can be used to attract a mate. A dark, drab color, on the other hand, can signal, "Okay, you win, I give up." But then they use that exact same ability for temperature. A chameleon will turn super dark, almost black, to just soak up that morning sun. And then, later in the day, it'll shift to a really pale color to reflect the heat and avoid getting too hot. So this is the part that just blows my mind. The big question is, how? How does one little animal pull off this incredible trick? Well, the answer isn't really biology in the way you might think. It's actually physics. It's nanotechnology. Now, your first guess would probably be that they have little sacks of different colored pigments in their skin, right? And they just kind of mix them together, like an artist mixing paint. A little yellow plus a little blue makes green. Makes sense. But that is not what's happening at all. Nope, not paint. It's pure physics. And what's really wild is that scientists only fully figured out the nuts and bolts of how this worked back in 2015. So this is pretty recent stuff we're talking about. Here's the secret. Deep down, under their top layer of skin, chameleons have these special cells called iridophores. And inside those cells are these teeny tiny crystals, guanine nanocrystals, all arranged in this perfect, repeating grid. You can kind of picture them like microscopic, perfectly stacked mirrors. But here is the absolute key to the whole thing. The color doesn't come from the crystals themselves. It actually comes from the physical space between the crystals. This is the whole magic trick right here. The best way to think about this is like a tiny living accordion. So when a chameleon is just chilling out, its skin is relaxed. This means that nano accordion is all squished together. The crystals are packed in super tight. And when they're that close, that structure reflects short wavelengths of light, which our eyes see as blues and greens. That's kind of their default everything's cool color. But when that chameleon gets fired up, maybe it sees a rival or a potential mate, it actually tenses up and stretches its skin. And what does that do? It pulls that tiny accordion open. This increases the space between the crystals, and this new, wider spacing reflects the longer wavelengths of light. And what are those? You got it. The yellows, the oranges, and those fiery reds of aggression and courtship. The scientific name for this whole phenomenon is structural color. The color isn't coming from a chemical pigment, like a dye. It's coming from the physical structure of the object itself. And you've seen this before. It is the exact same principle that makes the back of a CD or a DVD shimmer with all those rainbow colors. The color isn't printed on there. It's the tiny grooves physically bouncing the light around. So now that we understand the physics of it, we can actually start to decode the language. It's kind of like we can read a chameleon's mind just by looking at its skin. Okay, but wait a minute. That crystal accordion thing explains how they go from, say, green to red. But what about when they go from bright to dark for sunbathing? How does that work? That's not a color shift, that's a brightness shift. Well, that's where a second layer of cells comes in. They're called melanophores, and they're basically little bags of dark pigment, melanin, the same stuff in human skin. They act like a dimmer switch. The chameleon can spread this dark melanin out like a big umbrella over the crystal layer, making them look dark to absorb heat. Or it can bunch all that pigment back up, letting those bright, shiny structural colors shine right through. So here's your cheat sheet for reading a chameleon. If you see one that's a nice bright green or blue, it's generally calm. Everything is business as usual. If it starts flaring up with bright yellows or reds, it's feeling aggressive or territorial, so maybe give it some space. Dark brown or black can mean it's stressed out, submissive, or just cold and trying to warm up. And if it's super pale, almost white, it's probably too hot and trying to cool down by reflecting the sun.
Okay, let's wrap all this up with the big takeaways and one final thing to think about.
So to recap what we've learned, number one, chameleons change color for communication and for temperature control, not for camouflage. Two, the magic isn't from pigment, it's from physics, this incredible structural color created by that nanocrystal accordion. And finally, number three, all of this means their skin is basically a readable code for their emotions and what their body needs. Which, of course, leaves us with one last, fascinating question to think about. If your skin changed color based on your mood, what color do you think you'd be right this second?